All right. Good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation, you have a question for either of our speakers, please don't wait, don't hesitate. Just use your question and answer tab to submit your question, and we will try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we'll be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Observing Container and Kubernetes Workloads Across AWS with Datadog. Our speakers today are Aaron Kalin, who is a technical evangelist at Datadog, and Yaniv Bassam, who is Partner Solutions Architect for DevOps at Amazon Web Services. Gentlemen, thank you so much for joining me today. Really appreciate it.
Glad to be here.
Great.
Yeah, thanks for having us.
Oh, yeah, you're welcome. Well, Aaron, I know you're going to be kicking off the conversation, so I'm going to put myself on mute, take myself off camera, and I will see you again on the during the question and answer period.
Sounds good. All right, everybody. Today we'll be going over the many ways you can run containers on AWS and why you should choose one over the other. And that's kind of the theme of today's talk. So we're not going to dive too much into the minutia about containers themselves. We kind of just want to talk about the pros and cons of the different ways you can run containers on AWS. I'll be covering how Datadog can give you that unified view into all those different ways you can run containers in AWS. It turns out there's a lot of ways, especially once you're putting this whole thing together. But we'll have some recommendations and things like that for you too. At the end, I'll do a brief demo of Datadog because slides can only show you so much, and there's a lot that our platform has to offer. So I want to make sure that you get kind of the full picture of what's possible and what's capable, or what Datadog itself is capable of. So then at that point, we'll have some Q&A. Please feel free to throw in some questions and all that stuff. We'd love to hear your thoughts, and also just know if you've got any sort of burning questions about how do I run containers anyway. Containers are a very big, wide, and very hot topic. So you want to take it from here, Yaniv?
Yeah, sure. Thanks very much, Aaron, and thanks for having me today. I'll reintroduce myself. My name is Yaniv. I'm a Partner Solutions Architect, and I focus on DevOps in AWS, based out of Seattle, Washington. So container services, they are the core. They are core to our customer strategies. Customers are building their most sensitive, secure, and business-critical workloads on AWS container services today. And I am going to talk about a little bit, what these systems look like. In the applications front, our customers are building the backend, and they power their IT organization and consumer applications that drive the top line of growth. Many of our customers will also share services platforms, and they do that to help their dev teams move faster. These platforms automate software deployment and infrastructure provisioning, and provide guardrails for management, security, and governance. Customers are also containerizing their applications before moving to the cloud. They're containerizing their legacy, .NET, Linux, and Java applications. And lately, we've also seen that machine learning is a huge use case for containers. I can give you an example. Autonomous vehicle workloads are a huge use case for our container services, and other things like fraud detections or chatbots. So we often get questions from our customers, which services and technologies do I need to use in order to build my containers? And I'll talk next about some of those choices. Now, I know this slide can be a little bit overwhelming with the amount of services that we have. We have the broadest set of services, technologies, and tools that you can build the applications on containers, as well as deep integrations with open source and AWS partner technologies. And I'll talk about those integrations also a little bit later on. There's no right way to build on AWS, and indeed our larger customers build in multiple ways. They use both ECS and EKS, which I'll dive into, and container and non-container technologies. The core container orchestrators are ECS and EKS, and I am going to dedicate a few minutes to speak about kind of the decisions you need to make and the choice for when you select each one of these orchestrators. We also have a large choice of which underlying compute am I going to utilize when I run containers. So options like EC2, Fargate, ARM, AMD, and special purpose hardware. You can use also operating systems of your choice, including Amazon Linux, Windows, and then recently our new container operating system, which we call BottleRocket. BottleRocket is basically a Linux-based open source operating system that is purpose-built by AWS for running containers on virtual machines or bare metal hosts. You also have tools and abstractions, to build these environments, and these include CloudFormation or Terraform, Pulumi, CDK, and you can use also CDKs for Kubernetes and Amazon controllers for Kubernetes. There are many observability options as well. Today, you're going to see a very, very cool one with Datadog later on. I am also going to talk a little bit about how to keep state in your containers and networking, because there's a lot of aspects that you need to take into consideration when you select a particular container technology. All right, so as I promised, I'll talk about the core container technologies: compute, storage, and networking. So the choice of the orchestrator is important. This is the key integration point. It will deeply influence the rest of the choices that you make. One of the most common requests we hear from our customers is, can you help me? Can you help me decide basically which container service I need to use? We recommend, that most teams begin by selecting a container solution which attributes basically and most aligns with their application requirements and operational preference. There is no right answer, but some of the options are more suitable for depending on the applications that you build. So the choice starts with ECS, or Amazon Elastic Container Service, and Amazon EKS, which is Amazon Elastic Kubernetes Service. Both services support a broad array of compute options, and they both have deep integrations with other AWS services. But then let's talk about the differences. Starting with ECS, what our customers tell us that makes them choose ECS is the simplicity it provides. Amazon ECS delivers an AWS opinionated solution for running containers at scale. It reduces the time it takes for customers to build, deploy, or migrate their containerized application. Amazon ECS powers a growing number of popular AWS services and is trusted by hundreds of thousands of customers today. And some of the big names include Samsung, GE, or Expedia. Customers that are adopting containers at scale, seeking powerful simplicity, they should start with ECS. So if we take a look a little bit about what this means in an AWS environment when you put all these pieces together, Amazon ECS basically is set to decrease the number of decisions that customers make around compute, around network, and security configurations. For example, if you need a load balancer, or if you're familiar with AWS load balancer, ALB, or our network load balancer, NLB, these two integrate seamlessly with ECS. So you don't need to build, maintain generalized abstractions. These are taken care of for you. ECS is also friendly and familiar to developers with experience using Docker already. So this is, again, a great starting point if you want to move things quickly. Now we'll focus on the second orchestrator, which is geared towards the Kubernetes community with EKS. EKS was launched at June 2018, and recent stats show that 84% of Kubernetes workloads running in the cloud today run on AWS. So there was a pretty large adoption of that service ever since it was launched, and we keep building more and more features for it. Teams choose Kubernetes, like before we even talk about EKS, Kubernetes, they choose for its vibrant ecosystem community, consistent open source APIs, and broad flexibility. They rely and broad flexibility relying on that community. Customers like to rely on EKS just to handle things like the undifferentiated heavy lifting of security and operating Kubernetes at scale. There are things that you need that come with EKS that basically are set to simplify the way that you run Kubernetes in the cloud versus managing it on your own. Amazon EKS provides the flexibility of Kubernetes with the security and resiliency of being an AWS managed service. And if you used the managed service before, you know the things that it comes with. EKS is optimized for customers building highly available shared services platforms, and it's still based on open source. So big customers like Intel, Snap, Intuit, and GoDaddy, they use EKS to run their most sensitive workloads and mission-critical applications in production. So just to summarize all of this, customers adopting Kubernetes that want open flexibility, they should start with Amazon EKS. So we recognize that you might not be starting from scratch, and people like to bring in tools when they come into AWS. You may have chosen Kubernetes as the core, and have existing tooling. So if you see in this diagram, EKS gives you the ability to bring those services and build flexible environments. Of course, if you want to use EKS with all the AWS services, you can do that too. We continue to prioritize Kubernetes-friendly integrations with innovations like one of our recent ACK, or the AWS controllers for Kubernetes. Additionally, we work extensively with the open source community and AWS partners across the entire tool chains, trying to build solutions for our customers. Just some examples can be if you want to do authoring with VS Code and IntelliJ and still use GitLab or GitHub for sourcing and artifacting. If you want to use Jenkins for building your applications and Spinnaker for delivery. If you're familiar with the concept of GitOps and you're using Flux for GitOps already, if you have Terraform and you don't want to use CloudFormation and that is your preferred way to provision your infrastructure, and if you use Docker for composing or for modeling. So all these tools work together, and we're working on deep integration with EKS. So there's a lot going on in the portfolio, and I talked about ECS and EKS. I just want to summarize a few of the things we launched recently. And when I say recently, I mean in reInvent, our large event every year. So ECS and EKS right now both launched new consoles, and also support for customers managed infrastructure with something new that is called EKS and ECS Anywhere. And EKS distro, so you can run your containers everywhere, basically using the same control plane that you have in AWS, but you can still run it in your on-premises environment. Sorry, I jumped forward too early. Yeah, one more release that I wanted to talk about is AWS Proton. AWS Proton is the first fully managed deployment service for containers and for serverless applications. Basically, Proton gives developers an easy way to deploy their code in a way that enforces architecture and security standards, while still letting them move fast. The way it works is that central infrastructure teams build stacks, and the stacks are built in Proton. And these stacks basically define everything needed to provision, deploy, and monitor later on in their application components. Proton basically just ties together and coordinates all the different tools your developer needs for the resource provisioning. So the bottom line is, again, we're trying to build a tool here that you can connect to your open source systems with stacks through GitHub, and then simplify as much as possible the deployment process so that you don't have to deal with things like dependencies or which underlying compute you need to provision. There are more things that we released that are listed here, and you can find everything on our AWS page. All right, we talked about Amazon ECS and Amazon EKS, and I started teasing compute with Proton, selecting the right compute instances. But you still need a compute layer when you run containers. I mean, that's kind of the obvious thing. So AWS gives you a range of integrated compute options for where that actually happens. You can choose the right tool for the right job, and you can just get the right blend of cost, performance, and features. These are all considerations that you need to take when you choose a compute layer. On both EKS and Amazon ECS, you have the option of running your containers with these compute options that I have here in the slide. I won't dive into all of them, but let me just talk about one very important one, which is Fargate. Fargate, that's a serverless container compute engine. So this is where you only pay for the resources required to run your containers. It's suited for customers, who don't want to worry about managing servers, scaling them, handling capacity, planning for them, or figuring out, how to isolate container workloads for security. So if you're familiar with Lambda or with AWS services, with the serverless landscape, it's basically the same thing. You want to focus on your code, and you don't want to focus on all the undifferentiated factors of what's happening underneath that. So if you want to manage your containers at the task level, Fargate is the way to go. You can also run these on EC2 instances. That offers a really wide choice of instance type, including which processor to choose, like the storage and networking elements of it. It's ideal for customers who want to manage or customize the underlying compute environment and host the operating systems. If you still want to have that control, then you can go with the EC2, and then you can find your own cost models for that, for instance, using spot instances. In the hybrid world, we've released AWS Outposts last year. This is where you can run your containers with using AWS infrastructure, but you do that on premises. Basically, you want to make sure that you have a consistent hybrid experience and using the same control plane. The same reason why I earlier spoke about EKS anywhere and ECS anywhere. With AWS Local Zones, it's basically, if you're not familiar, it's an extension of an AWS region. So it's suited for customers who need the ability to place resources in multiple locations, but closer to end users. And Wavelength is basically an ultra-low latency mobile edge computing, and it's suited for 5G applications. It's interactive and immersive. It's suited for these applications, for their interactive and immersive experiences, and for things like connected vehicles. So, there's lots of different varieties, and again, we are kind of thinking, what's the best way to do it, and what's the best way to run it. And there's things that you need to think about. One of these things, is storage. As companies containerize more of their applications, they often find that those applications require persistent storage. It's either because those applications are long running, and need to persist state for high availability, or just because an application wants to scale out around a shared data set. Just to give you some examples, developer tools like Jira and content management systems like WordPress or Drupal, they use persistent storage to achieve high availability through an active standby model, often across different AWS availability zones. There's other use cases like machine learning. Customers use EFS to store shared data sets and data scientists' home directories, basically allowing them to train these models in parallel across multiple containers. So that you understand how it works in a container. Data in a container is ephemeral. That means that if the container crashes, it will start up in a clean state. And any data associated with that, it's going to be lost. So this presents the problems of stateful applications, meaning they change over time, such as databases or workflow-based applications such as Jupyter Notebooks. In order to maintain state, the application writes to a persistent storage volume, which allows the application to basically restart with all its associated data intact. The two AWS services commonly used for these deployments are Amazon EFS and Amazon EBS. If you're running transactional workloads that require low latency, you should choose Amazon EBS. And if you're running containers that require sharing between them, or if you're running your cluster across availability zones, we recommend Amazon EFS. So there are several common networking tasks associated with container application. Container needs to join a network. So in order to do that, you have Amazon VPC. Container application needs to be able to discover one another, so you can use things like AWS Cloud Map. You may want to deploy service mesh in order to set up an application level network. And basically, this will allow you to control network traffic routing. For this, you can choose things like app mesh. You also need to be able to load balance incoming traffic based on either layer 7 protocols such as HTTP or layer 4 such as TCP and UDP using ELB and AWS Load Balancer Controller. So just going over some new features and launches in our compute level or compute offering. Fargate now supports persistent storage with EFS, which is pretty huge for managing to have that persistent storage that I mentioned running the container. There's a new ECR public registry that allows developers to discover and use container software that vendors or open source projects and community developers share publicly. I won't go over the rest of the items here. I just encourage you to check out the AWS Container Roadmap. We have a public roadmap on GitHub where you can either +1 or suggest new features, and we can have a look at those that you submit with our open source teams. So as you can see, that's a lot to unpack, and there's a lot going on when you run containers. And a key element, to successfully operating them is being able to observe your services and see everything that's going on within your systems. So with that, I'll pass it over to Aaron to talk about container observability using Datadog. Take it away, Aaron.
All right, thanks, Yaniv. Since we're all sharing where we're from, I forgot to mention I'm hailing from Chicago, where we are currently thawing out. So I'm here to talk about the Datadog side of things. So Datadog, we have a lot of great AWS-related integrations that give you a lot of out-of-the-box insights into your container deployments, no matter how you sort of deploy them. In fact, I would say that Datadog and AWS have a wonderfully great relationship, and our many integrations at AWS kind of showcase how deep that relationship actually goes. To date, our first and largest deployment in terms of where Datadog exactly lives is still with AWS. So that'll give you kind of an idea of like how deep our integrations have already gone, just because as we like to ironically say, we dog food our own product. So we actually watch Datadog with Datadog. It sounds very meta, but we're very big about that particular thing. So let's take a look at some of the out-of-the-box integrations that you get. So the first one I want to show to is the AWS dashboard. So if you link an AWS service to your Datadog account, say if you start up today, you do the Datadog trial, give it a shot, and you connect your AWS services to it, we will generate this dashboard for you, which you can clone and customize as you see fit. But this dashboard has a lot of information on it to start, because we try to cover every AWS service that we can observe. So it's automatically added in. You can take all those services that Jan had mentioned, you can kind of see already listed in here. But this is a great general overview of everything AWS offers. It could be a little overwhelming though, even though you can scope this down a little bit based on sort of the service where it's deployed. Like maybe you can scope this down to regions, so you can see if you've got multiple regions with AWS and things like that. You can kind of scope this particular look down, but it's still a lot of information. So let's zoom in a little bit more to, say, EC2. So if we go to the next slide, I'll show you what the EC2 dashboard looks like. So if you deploy, say, Docker on EC2 instances, so you can do your own containers, maybe you're bringing your own orchestrator, something like you want to run your own Kubernetes. I personally wouldn't recommend that, because Kubernetes is a pretty intense orchestrator. There's a lot of stuff that comes with it, because it's not just the Kubernetes orchestrator. There's having to manage etcd and all this other stuff. There's a lot of things that come with it. Maybe you're using Rancher. Rancher is a pretty good orchestrator for this stuff too. They kind of give you a lot of out-of-the-box things right off the bat. Or maybe you've heard of HashiCorp and their products. So we mentioned Terraform before. They have a thing called Nomad, which can do not just container-based workloads, but also things that are not in containers. So you have a lot of options when it comes to that. So if you deploy to something like EC2, you gain a lot of flexibility there. So if that's something you pretty much value, but you're okay with handling all of the additional resources that it takes on, at least we can give you a very nice overview of what's going on with those particular instances. So this will help you see how they're performing overall, kind of in concert, but you can still scope this down again to sort of where they live and potentially what they're doing. Like the more information you add about your instances, or if you especially use instance tagging and stuff like that, we pull those tags in automatically on the Datadog platform. So next we'll go over to ECS. So let's, this is a containers talk, right? So let's talk about ECS instead. So here we can scope the big overall view in the ECS by ECS cluster or anything more specific like that. Maybe you have particular deployments that you're doing. So if you're just doing strict containers, you are okay with Amazon's opinion on that whole running of that. Honestly, it would probably be one of the more simple ways to start containers on the platform, as Yana was mentioning. So if you have a bunch of container workloads, you just want to run them somewhere, but you don't want to worry about maybe spinning up an EC2 instance, installing Docker, maintaining Docker, running Docker, and then figuring out how you're going to orchestrate that whole thing, Amazon has a really, really good way to do that. But the cool thing is we can show that in these dashboards. But what I do like about this view and even the previous views that you saw, if you notice, because like off to the left or maybe to the right, there is that event stream off to the right that you can see there. I'll show it a little bit better when I get to the demo side of it. But the event stream is going to be scoped by service too. So if you have a bunch of different services from Amazon, because there are quite a few, as you saw from that one big slide, there's a whole event stream of what's going on. So are containers being shut down, killed? Are they being restarted? Are they scaling because there's a lot of demand coming in? You can kind of see that sort of in real time. If we ever get back to physical offices and you have that, or if you got a really cool home office and you've set up a large TV, you can put these dashboards up in big screen mode. We do have a lot of those at the Datadog office. So you can kind of get a really good, like at a glance, what's going on in your infrastructure. And you can even swap between these views to see what's sort of happening in the whole. Sometimes you can spot different issues going on with your infrastructure through this big overall view that you might have forgotten to keep as a monitor on there. So like right now, you can see the event stream off to the right there. We'll show a little bit more in the demo as well to show kind of how that event stream system works. So next, let's talk about some serverless, because that's also another, I'd say maybe simplest option to start with, because Yana mentioned that there. So there's Fargate, and some folks might be thinking about Lambda as well. But this is our Fargate integration, where we kind of give you an overall view of what's going on with your serverless functions and how they're operating and performing. Because the big name of the game there is you want to make sure that you have some good memory efficiency and you have good I/O throughput, because you're charged based on sort of their usage itself. You don't have to think about the container runtime, all that other crazy stuff, but we can keep a very good eye on that with this particular viewpoint. But maybe you're running Docker on an EC2 instance, like I was mentioning before. So let's move over to the Docker slide next. So this one is out of the box if we detect that you're running Docker. So if we install the Datadog agent onto those EC2 instances and we see that Docker is living there, we will automatically add this for you if you let us do it with the auto detection, things like that, or if you configure it in the agent. We try to do a lot of stuff out of the box for you, so you don't really have to think about it. We'll just see that those things are there. We'll try to configure it the best we can and then get that up and running for you so you at least get a nice viewpoint into it. Now, if you fit into that EC2 scenario that I was mentioning a little bit ago, where you want that flexibility of how you deploy and run your containers, you'll get this out of the box. And then if you run those EC2 instances, you can watch them on that Ec2 dashboard. But you're probably going to want to know what's going on with your Docker instances as well to see, if Docker itself is having a good time, is the CPU load going crazy, that sort of thing. Because EC2 itself will show you kind of the host level instances and all that stuff, those VMs that you're running. But then if you're running Docker, you're now looking at the container side of things. Those are kind of two components that you have to keep an eye on. And this will show you kind of how the network is working, how the scaling is sort of working in that regard. And I know we're showing Docker here, so some of you might be also thinking about Docker Swarm. What about that? And that it is another option for orchestrators, but there's a lot of questionable feature support since they got bought a couple of years ago. So I would personally not recommend it. I've tried using it too. It's really complicated, but it's also extremely opinionated. So if you're going to go with an opinion, I would personally go with something like AWS ECS instead, or even EKS if you're looking to jump into the Kubernetes pool. But we collect so much information too on Docker alone that I can't even show you everything on the screen. This is why we're going to do the demo anyway, because this slide is like, as you can see off to the right, there's stuff that's getting cut off. There's a lot of information we collect all at once. Now, speaking of orchestrators, let's talk about the big one, Kubernetes. That's one with a very, as Jan had mentioned, a very rich and vibrant community. It's very active. There's a lot of people working on it. The Cloud Native Computing Foundation has a lot of projects out there. Kubernetes is pretty much their flagship one. Since we mentioned it, though, we do have a great dashboard for it. Datadog itself deploys Kubernetes. We have a whole series on that I'll mention later on in this presentation. So if you're really curious about how Datadog does that whole thing, we have a lot of great information about that. But if you're like Datadog, you probably have multiple clusters across multiple nodes and multiple regions with tons of namespaces. And this kind of gives you that great overall picture of sort of the health of all of that. So even if you're running this on EKS and all that, we can still take a look at it as if it's just a typical Kubernetes cluster. So we'll be looking at all the different pods that are running, how those are working. If there's any event notifications, those again will come through on the left-hand side there. But we make events a little bit more robust in this because you really want to watch, sort of what's going on with not just Kubernetes and what it's doing, but also if there's anything else happening within the clusters themselves. But networking is, again, that bigger thing that we want to watch. We're not going to touch on it too much here, just because that can be its own webinar alone. Like, networking is a very complicated subject, especially when you get to containers. But there's lots of options. And again, we can still look at all that. But let's get a different views because we're talking about performance here. So let's instead look at sort of the infrastructure level view that we are somewhat famous for at Datadog, because that was kind of the demo that we always show. If you've ever been to our booth at any of the reInvents and things like that, I'll show you the classic hexagonal infrastructure view. But at Datadog, we kind of treat those sort of homogeneously, because if you look at the very top, we have the host map, which is kind of the thing that was our bread and butter to start with. So usually we were running like EC2 instances or something like that, maybe some bare metal. And those are sort of potentially physical hosts. But if you think of containers kind of as like miniature versions of those hosts, we also treat that as additional infrastructure. So we kind of look at them almost in the same generalized category. I'm not saying they're exactly the same. I know there's a lot of differences and they're a lot smaller. One is way smaller than the other, of course. But we try to keep it in sort of a single pane of glass that's easy to pivot between each of those different types of workloads, right? So as you can see here, no matter where they're running, even if these instances that you can see here, like all those little logos there, that's all Kubernetes. So these are containers that are running within potentially Kubernetes pods and all that stuff. I kind of giving away a bigger feature that just shipped. So if you look at the top left up there, next to containers, there's pods and deployments. So we now actually have a Kubernetes tailored view of this look here. So if you want to look at deployments in general, which could be a ton of pods that are part of that, or you just want to look at pods themselves, because pods can, again, be one or more containers. Maybe you have some sidecars going, all this other crazy stuff. Like I said, Kubernetes could also, again, be its own webinar. It is a very large orchestrator. It gives you tons and tons of flexibility, but again, there's the cost of complexity. So you have to really understand what's going on and kind of what it's doing. But again, we try to give you that really nice, helpful view of sort of the performance overall of what's happening there. And now, not to be outdone with that, because we mentioned serverless before, we can give the same kind of view. In fact, if you just moved over to that next, so you already got that slide up there too, but if you remember from the top there, there's just another tab for serverless, because again, we still treat serverless as its own kind of infrastructure component. So each of these serverless workloads, I know in here in the photo, we have a lot of Lambda functions. This is just the best I could do for the demo purposes and getting a really nice screenshot. But you can do the same thing for Fargate here as well. We watch all those as well. If you add Datadog instrumentation to each of those, you can kind of think of those as like little applications that are running, and you can watch how they're performing, how well and how often those invocations are happening. But my favorite part of this view is off to the right. If you see the insights section there, we see errors, high memory, high errors, all that stuff. We tried, as we watch your infrastructure, to see if there's any anomalies that our AI can detect and say, there's a lot of memory getting used on these functions here. They're calling this function a lot too. So it's potentially costing you a lot more than you can currently see. And we try to estimate the overall usage costs of those too. So if you're more concerned about infrastructure budgets and things like that, especially around serverless functions, this gives you a really easy way to look at what's going on and then try to resolve those issues. Because if you click on any one of those insights, we'll link you to documentation that gives you a lot of great out-of-the-box stuff to show you different techniques and things you can do to kind of reduce the memory usage, or make sure that if there's any errors coming up, you can kind of track them and resolve them, so you can deploy and then compare those deployments and how well they worked when you did that. So again, slides can only show you so much. So I think pictures, they say, are worth 1,000 words, but I think a live demo is worth so many more. So let's get into a demo here, or I can give you a tour of kind of all these things, because again, there's so much that we can offer at Datadog, and screenshots just honestly don't do it justice. So let me go ahead and get my screen shared over here, and I will show you. See here, hopefully this works. There we go. All right. There we go. All right, so you should see my screen now here. I'm going to go ahead and pull up my notes here to make sure I'm on track. All right, so this is the AWS overview that I was showing you earlier. So this is kind of this is the live view in a demo environment. I can't really show you production. There's a lot of reasons I can't show you production, but this is a great demo view of everything going on that we can see. And as you can see, there's still scroll bars here. I can still move around. There's a lot more information that is off to the side here that you just can't see. And it's not so much that you'll be looking at this constantly. Again, these are really dashboards that give you kind of that big overall snapshot view. And then from here, we can zoom in by account. We can zoom in by a particular region. So if we have this deployed elsewhere or in multiple regions, you can kind of scope this dashboard to look more closely at those particular regions. So maybe you have a large deployment in the US East, for example. And then maybe you got some new stuff in US West, so you can have more regional, failover options, et cetera. There's different ways you can run this stuff that way too. And you can also scope this generically about any sort of tags as well that you add. The more information you kind of give Datadog that is more particular to the types of containers you're running or sort of what their workloads are, the more flexibility you get inside of these views. But I did want to show I showed the filtering by that, but we can also change the timeline. I can even copy paste this. So if there's a timeline I'm zooming in on and I want to share that information with someone else, I can literally copy paste this, give that to someone, they can paste it right back in. This is kind of a newer thing that we've added. You can also put in, say I want to show yesterday's numbers. You can literally type in yesterday and it will key back over to that. It's kind of one of my favorite new things that we I would say somewhat quietly rolled out. It's we have a lot of little things that we add. We try to announce a lot of this stuff as much as possible. But the other big thing too that you can't see here that I can't show in the screenshot is if you go up to the top left here, the AWS overview section, if you click on that, we give you a set of suggested dashboards, also any users that might have been in this dashboard a lot. So folks that might have been, say if this is a custom dashboard, for example, and we have a lot of coworkers that are editing this dashboard. If there's some new thing in there or something has changed, I know who's been changing it ideally. So then I can maybe go ask that coworker, hey, why did you modify these timelines, these graphs? Did you add these things? You can go find out, sort of what's happening there. But we also can link to other dashboards. And this is based on activity. So for each account, which dashboards are kind of the hottest in relation to this one. Like if I pivot from this one to say, this screen board, or if there's a different platform I'm going to, we try to track that. It's a little weird in the demo org here because we've got so many different services and different things that are going on here. This gets a little crazy just because people pivot to a lot of different things. But my favorite part of this here is the documentation help. So we not only link to our engineering blog, which if you haven't been to is really helpful. There's a lot of great information up there. But we also link to our documentation, which as I say, this, it is part of my team that we handle a lot of the public facing documentation. We care a lot about our docs. So if you ever have any feedback about that, et cetera, we are always all ears and we generally fix those really, really fast. I've contributed to them as well. We try to go above and beyond to make sure that you have all the information you need to deploy with Datadog. So if I wanted to go to any one of these here, like this is linking to a blog post, for example. So these are the key metrics that you need to know when you're looking at AWS in general. So we actually, section this off here. So if you want to look at any of these different services, they show those dashboards I was talking about before. We kind of give you a lot more information and reading that you can go by. So you don't really have to worry about trying to figure out, okay, what is AWS anyway? Which services are going to be, what do you want to look at for each of these services, that sort of thing. Like, why am I seeing all these numbers? We kind of try to explain that as much as possible. So from there, let me show you the Docker view that I was mentioning before. Again, a lot of information that comes up here on this side. So in particular, I'm going to start using some of the scoping here. So let me go take a look at, remember we have that single pane of glass. So no matter how we sort of orchestrate these containers, even though you're installing Docker, maybe you're running Kubernetes. So let's take a look at a kube deployment from here. Now, if you do have Kubernetes attached to your Datadog account and the agent can see it and start to collect data from it, especially if you have the cluster manager and all that, we try to tag as much information about those pods and also the containers that are running within them. So I want to go take a look at a Redis cluster that's running here. So I'm scoping this now by kube deployment Redis. So I have a kube deployment that's out there called Redis, but you can name it anything you want. I'm naming it basically what it is. So I've just scoped this big, large view of Docker into just that particular snapshot, because this could be a set of containers that are running. Because remember, pods can be one or more. So maybe there's a bunch of pods that are running. It doesn't necessarily matter where these are all running, but I'm just looking specifically at my Redis cluster now. So this will give me kind of the overall health of that, maybe Redis as a core feature or a core service where if that goes down, things are not going to be great in production, right? So maybe I want to scope the view to this. So that's an easy way to kind of just go through there. And again, that helpful information thing at the top left that I was talking about, again, I can go look at the Docker integration information. Maybe there's some things that are missing here that aren't correctly set up. So this is where we can go to the Docker integration information and maybe tweak a few settings or things like that. So that way the agent can look more closely at what's going on with Docker. And then from here, I'm going to go into that famous host view that I was talking about. So if you've ever been to our booth, especially at reInvent, which is a really big event, you might have seen this. This is kind of like the thing that is, I would say, the most iconic part of it is we have this crazy hexagonal view. And now traditionally, it's always been through hosts, but especially once we started getting container monitoring, like right now we have all these hosts grouped by availability zone. So you can see we have a lot of deployments going on here in this demo. A lot of it is just to kind of show just the overall scale. So if you want to see the very big zoomed out picture view of everything happening, that's that. But again, I remember I mentioned that we kind of treat hosting containers almost as your infrastructure. So if I change this from host to containers, this will switch to a container view. It's not the hexagonal thing anymore. We actually show them as little boxes, kind of so you have a visual separation differentiation there. But when you go to that, you can click on any one of these containers. There's a lot of them here. So I'm just going to pick one at random just to show. So this is a container that's running. It looks like it's running via Docker. We have information already here about the CPU usage of that particular container, not necessarily the host it's on. We know which host it's deployed to. So this one is on the Azure Kubernetes service, for example. We have a lot of information around the container itself, like which cluster it might be part of, if there is a deployment ID or information there, any sort of Datadog related tags, all that stuff. So this kind of becomes a big tag cloud of stuff. So making sure that you rein that in terms of, what the sort of service is, what it does, the type of application. We also track version numbers more particularly now. So a newer thing that's being deployed out across our different services is tracking version number information. Because generally speaking, you're probably doing applications, you're probably doing released versions of it, and being able to compare performance of one version versus another. Maybe you did some optimizations and you really want to know if that optimization worked, especially in a production workload. And we have ways you can compare that. So having this zoomed in view is pretty handy. Let me load up the more particular containers view now, because remember I was talking about that performance side of things. This kind of gives you the general overview of your infrastructure. This is kind of like the okay, look at my landscape, right? This is everything here. But chances are you'll probably also wanted to know, like, how are my containers performing overall? Can I compare them against other ones, that sort of thing? So that's where the containers view comes in. This is also still under infrastructure. This is back where we were before in those last two slides. So again, here we've got a whole bunch of, looks like Kubernetes related containers here. These are all from a production app that's running. And as you can see here, we're kind of just watching this based on memory. I can also keep an eye on just CPU in particular. We get the nice scatter plot graph, but I could also look at this more of a time series. It's a little crazy just because of how many containers are currently here. So I probably want to scope this down a little bit here. So maybe I want to know how my Kubernetes environment is running. So let's go ahead and filter by here.'re going to use the kube system tag. So I want to know how Kubernetes itself is running, because maybe I'm deploying Kubernetes myself and I want to take a look at that namespace. So I'm going to filter this now by kube system just to look at those particular containers that are running. And now we can kind of watch the performance of it. And even seeing spikes like this, I might want to go take a look at what's happening there. So this will give me that overall view of those, if those containers are running. If I click on any one of these two, I can get more zoomed in information about that container, kind of similar to that other view you just saw, except this will give you a lot more information. And now from here, this is where I think our product really, really shines to show you a lot more data about your containers. Now, I'm not going to go too deep into it because, again, this is a whole different side of our product, is the network performance monitoring, or NPM as we call it. I know it's kind of an unfortunate name in terms of its shortness, because if you're a developer, if I say NPM, you might think a different thing. But NPM for us is network performance monitoring. So if I go here, this is the typical metrics that most people have been tracking all that time. But maybe those containers are emitting log information. I'm doing live tail right now, so I'm getting live log data right off of the container. So if there's anything happening here, I'll see it come flying out from the container. I'm not sure if it'll show me here, but I can maybe go zoom back probably maybe another hour or something like that if there's anything coming out of the container. But I'm going to move to if there's any application traces. So if you're using your application performance monitoring product and you're deploying and monitoring those traces, we can try to correlate them across the container that they live in. So if we're getting all of those trace IDs along with which host they are, because we track containers kind of like their own hosts, we can then correlate those trace IDs and everything there. And then the network part that I was just mentioning, this is where we get to look at the network side of things, which again, if you're getting into more advanced deployments with Kubernetes, this is something you want to keep a closer eye on. You want to know sort of, are your services with Kubernetes talking correctly? So you'll see things like, I know we've just added the DNS side of that. So we have DNS monitoring. So DNS misconfiguration has taken down many a Kubernetes cluster, especially lately. It's not been a wonderful thing, but if that ever has any issues, or if you do service discovery, it's not configured correctly, this is kind of where you can start catching those. But this is where you can see more specific of like the network volume, but also kind of more specifically if there's any throughput issues, but also if there's any problems of like if it's sending a lot of data but not receiving anything, potentially there's some network policies that you might have added in on accident that have quite literally disconnected a container, because that's where the network policy thing gets a little tricky when you start getting into more advanced container-based deployments. And let's see here. I want to also show you one more thing from here. Let me close this out real fast. I want to show, since we're talking about AWS stuff, I want to show some ECS clusters. So let me type in ECS cluster. There's a lot of data in here, so it's going to take my computer a second to kind of show it all. There we go. Still fairly performant though. Here we go. So we got some Fargate stuff finally. I talked to a few people and we made sure this got up here, but we've got some Fargate serverless stuff running right here. So I wanted to show you kind of the overall view of that. So again, we can, this is not going to be quite as in depth as you would normally have for say an actual container necessarily, because a lot of that stuff is being already handled for you by AWS. So if you wanted to run, I would say probably the simplest deployment of containers, and they put containers in quote marks. If you're going to make just a function that needs to run and do a thing, because that's where kind of Lambda became very popular. Fargate is kind of that other thing where I need to sort of run an application or serverless stack, but I don't want to worry about the container runtime. I don't want to worry about the host that it's running on. I just want it to scale when I want it to. So the thing you really want to pay attention to is sort of like the memory usage and things like that, or at any of the error rates. So if your functions are returning errors, that's kind of the thing you pay attention to. It greatly simplifies the things you typically need to worry about. But you are trading off a lot of stuff when you get there. You're trading off a lot of that flexibility. But there's larger companies out there that have deployed a lot of stuff to serverless, because it does solve a lot of very simple or very particular issues. And I would say it's probably the easiest way to get into sort of containers as a whole. But you can always move up from there to say ECS. I personally wouldn't jump into EKS unless you really know what's happening with Kubernetes. Even though Amazon's running it for you, there's still a lot of stuff that Kubernetes does that you need to understand before you really jump into it. But the nice thing is that if you're tracking all that stuff with Datadog, it doesn't really matter how it's sort of running, where it's running, even across the AWS footprint. It's all over the place. So this at least gives you that kind of homogenized view of that. So even if you start going to multiple regions with AWS, or if you start doing multi-cloud, this will allow you to see all of that in one area. So it simplifies things in general. I think from that point on, we should go ahead and go right into questions. I will go ahead and stop sharing my screen here.
All right, guys, great presentation. We have gotten some great questions in so far, but there's plenty of time. If you guys have a question, please go ahead and use your question and answer tab, and we will get to as many as we can. Let's go ahead and dive right into the ones we have. Excuse me. First of all, Garrett asks, when would one use Fargate versus when they may use Lambda?
Yeah, I can take that. I think the difference, first of all, let's understand what Lambda and Fargate are, and then we'll talk about the differences of choosing the underlying compute for running a container. So Lambda isn't geared for deploying containers on. Lambda is basically for developers to take their code, package them, and then all they have to do is focus on writing the code for the application. And then after they package them, they just choose CPU and memory and allocate them to that function. And whenever that code runs, that's when the usage is actually happening. So that's how you're also build. You're build according to the amount of time that your function or your code is running. Where Fargate and Fargate, I would say that the better question is, when would I select a Fargate and not running it on an EC2 server or an EC2 instance? Because Fargate is also a serverless in the way that you also have to select CPU and memory, for your containers. Actually, you have basically 50 different ways or 50 different combinations of how many CPUs and memories kind of setting you can choose. I would say that understanding the difference between running it with Fargate and EC2 really comes down to the fact that with EC2, you need to manage your services, your tasks, but there's one more aspect here, which is, you're responsible for the container instances and that compute aspect of your architecture. Whereas with Fargate, you focus only on the tasks and the services. So the end goal is focus on writing the code for your application, and then let AWS manage all the underlying scaling, networking, and simplified, and also to simplify the security concepts of making sure that you can authenticate into those containers.
All right, great. Next question here from Brian. He said, I think this one is for you, Aaron. This is a great detailed data for supporting systems. Is there a business service view that is possible? E.g., a financial services company provides banking services that are supported by dozens of applications that have dozens of components existing in dozens of containers.
Gotcha. I think what you might be, it actually seems like I'm trying to figure out exactly sort of the use case here with that. I would at first glance, I would think, or at least from first reading that, I would think that would be somewhere along the lines of maybe a custom dashboard where you scope those on particular services and maybe get a little more detailed about which particular tags you're looking for, that sort of thing. Because at least with the dashboards I show, those are the ones that come out of the box that we just configure for you. Now, you can always clone those dashboards. There's a clone button at the top left, and I can just make my own custom copy of it, throw out certain time boards and all that stuff. I want a different graph, or I want to change this or that. You can customize them to your heart's content, or just start a brand new one. In which case, from there, I would scope that dashboard to a particular set of those services that you're really concerned about. If you're looking more at like the business related goals around those, this is where you want to consider things like SLOs. We have a whole section on that, and again, based on time, I'm trying not to get into too much there, but we definitely have a whole thing about talking about error budgeting and all that stuff. So if there's a particular business goal that you have around those services too, you can also put that in a dashboard of, okay, what's our error budget, how we burned it, that sort of thing. You can have that up on that view. Hopefully that answers that question. If not, I'll check in the chat to see if there's something more specific you want to ask. But hopefully that answers your question.
All right, great. So we have about 5 minutes left for question and answer period. There's time, guys. If you have a question, go ahead and put it on in, and we'll try to get to it. Here's a question for you. What are the incentives to run serverless and not EC2?
Yeah, I think that in part, what I answered for the previous question was probably an answer to this question as well. But just going over this again, it comes down to the amount of things that you need to manage, and there's a lot of things to manage when you run a container environment. You have to look at things like networking and security. If you're familiar with AWS IAM, then IAM is the way that you provide access to some services, and to provide this access and the security into your containers and to manage that network and everything that goes with it. Basically, Fargate seeks out to simplify these concepts. So with Fargate, which is the serverless offering, you're looking only at your tasks, and then you just configure a few things to set that up. It's not a deep dive about Fargate, and I'm happy to provide documentation for that. But the advantage is from, I guess, the customer or the business perspective, is the fact that serverless simplifies the amount of time that it takes for you to manage and run your underlying compute. Where it takes care of that, all you have to do is take care of your containers and focus on the task level activities.
All right, great. I think we have time for one more question. Carlos asks, what is the average response time in a serverless Fargate deployment? I know that, for example, in OpenShift, it is about 4 seconds from the start of the request until the serverless instance responds to it.
Yeah, Carlos, happy to take this offline. You can reach out to me. I don't have the exact number right now, but yeah, feel free to reach out on LinkedIn, and I'll definitely get you the answer.
All right, great. So one more question just came in. Walter asks, is Datadog just for AWS?
Absolutely not. So we've like I was mentioning before with multi-cloud, we can work across multiple clouds. Actually, Datadog itself is deployed to not just AWS, but if you are a European customer, you're actually on a GCP cluster, so Google Cloud Platform. And we are in the midst of rolling out all the stuff for Microsoft Azure over in the United States. So we actually ourselves are multi-cloud. And that's a lot of why we sort of built and geared our product for that. So if you are in any other major cloud and all that stuff, if it's one that, that's up and coming, by all means reach out to us, and we will absolutely look at prioritizing work around getting better integrations with them. But for the major cloud providers, so Microsoft and AWS, like we were just mentioning today, and then also Google for their cloud platform, those are all very, very well integrated into our platform. So absolutely. So multi-cloud is a big thing these days, especially for us.
Awesome. All right, let's do one more, and then we'll close it out. Let's see. Let's see. Yes. Okay. Okay. Here's a great one for you. How can I share my Datadog dashboards with other teams?
Great question. So there's a few different ways you can share them. So you can share them publicly. It's like if you're going to keep it within your team, then generally it's just going to be you give them the link. You can start. You can also just share like the actual dashboard link itself. Now the caveat with that now is we've recently rolled out RBAC, or role-based access control. So if you are an admin of an organization, you can actually restrict access to not just creation of dashboards, but who can read and what. You can actually set those specific controls. So if you have sort of business concern about separation of information, et cetera, you can restrict that. So there's sometimes where you might get shared a dashboard that you may not have access to, which I'm sorry, that's more of an organizational thing. That's not our, I can't answer that part. But if you want to share it publicly too, it's very easy to generate a link that can be shared up front. You can even control like sort of the timeline for that. So if you want to have a sort of a public dashboard to kind of show your customers that you are actually watching your infrastructure and what's going on there, you can absolutely do that too. Hopefully that answers your question.
All right, great. Well, we're about 3 minutes to the top of the hour. So unfortunately, that is all the time that we have for the question and answer period. I do see that we have gotten 1 or 2 more questions in. And guys, I apologize that we're not going to have time to get to them during the webinar. But please know that the folks from Datadog and AWS are getting a copy of all of the questions that came in. And I'm sure that they will be more than happy to follow up with you after the webinar and get your question answered. So Mohammed and anybody else who might have a question, please, if you still have a question, please go ahead and get it on in. They're going to be getting all of them. So also a quick reminder to the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can go look for it there as well. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, let's see. I think the only thing that I have left is to do the drawing for the $425 Amazon gift cards. So without further ado, let's go ahead and get to that. Our first winner today is Michael S. Congratulations, Michael. our second winner. Yay! Second winner is Jose C. Congratulations, Jose. Our third winner is Manuel C. Congratulations, Manuel. And our final winner is Brisa. Congratulations, Brisa. Okay, we'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. If you don't see anything there, please check your spam folder. All right, Aaron and Yaniv, thank you both for a great presentation. I am a huge fan of the demo, so I especially enjoyed watching that, but chock full of great information all the way around. So thank you guys both for such a great presentation. Really do appreciate it. I know, judging from the conversation or the chatter from the audience and the questions that came in, they got a lot out of it too. So thank you again. I really do appreciate it.
Thank you.
Yeah.
Thank you. Have a great day.
I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.